Okay, so we wanted to finish up our discussion about periodicity today, or what causes the periodic trends. And so, first of all, you'll notice there in the pink box, and along with the other things that are on this slide, this is a major thing that we want you to know. And so, the periodic trends, which are also called periodicity, of atomic size or radius, ionization energy, and electronegativity can be explained by the trend in that force of attraction. Okay, that force of attraction is our why, our explanation of why we observe these different things. And so again, that force of attraction is between an atom and its valence electrons, or its outermost electrons. So you'll notice here that we have our kind of bringing this picture back, we have our atoms going down a group. And as we go down that group, we're getting more and more layers of electrons. But it's a little bit hard to see right now. But if I stop moving my mouse, the arrows are representing our force of attraction. And that force of attraction is decreasing as we go down the group. But notice that we've also got three atoms there going across a period. So period, three elements. And notice that as we go across the period, we actually see that force of attraction increasing. And so that's really the trend that we want to think about, that as we go down, our force of attraction is decreasing. As we go across to the right, our force of attraction is increasing. So when we looked at our periodic table here today, we can kind of think about labeling the two sides of it. And so the stronger force of attraction is going to happen in that upper right-hand corner. The weaker force of attraction is going to happen in the lower left-hand corner. And again, ultimately, it is, the two factors of distance and the number of protons that are determining that force of attraction. And so like we talked about in class today, if we compare two elements in the same group, magnesium and barium, we're going to have, in this case, magnesium being the element that has the greater force of attraction for its electrons, and because it's higher up in the group. And calcium is going to have the lower force of attraction. So for this question, our bromine then is going to have the greater force or stronger force of attraction. Does the attractive force increase or decrease across a period? And so again, we're going to think about the fact that across a period, it is going to increase, and down a group, it is going to decrease. So we want to keep this in mind as we get into our other slides that are applications of this. So this slide is asking us to think about metals and which is correct for metals. And there's a lot of information in these different multiple choice things. So here's a few test taking skills. Let's break it down along the way. So first of all, if I'm thinking about metals, I want to think about where they are on the periodic table. And so you'll notice that periodic table that we slipped in here, okay? And metals are on the left-hand side, really, and nonmetals are on the right-hand side. And so the first thing that I notice when I look at these answers is that they're the same kind of structure throughout. And so if I look at A and B are different because one says small radius and one says large radius. Okay, so if I think about metals compared to other things on the periodic table, metals are over on that left-hand side, and they tend to be things that don't have such a strong force of attraction. And so because they don't have such a strong force of attraction, they're actually going to have a large radius compared to other atoms. So we're going to keep everything with large radius. Next, I noticed that it talks about ionization energy. So ionization energy is really the pull of an atom on its own electrons. How strongly is it pulling on its own electrons? So if there's a higher force of attraction, there will be a higher ionization energy. So things with high ionization energy should be up in that upper right-hand corner. Well, those are nonmetals. Those are not very like metals. So when I'm looking at that characteristic, I can then cross off B because metals will have low ionization energies. And finally, I can look at my last characteristic, electronegativity. And electronegativity is the attraction that an atom has for the electrons of everyone else's atoms, okay, other atoms. And so high electronegativities actually go with high ionization energies. And we just said this had a low ionization energy, so it is going to have a low electronegativity. So D should be our answer for this one. Let's take a look at another. So in this case, for this next one, we're going to look at these three elements: lithium, rubidium, and iodine. And first of all, notice that lithium and rubidium are in the same group. Rubidium and iodine are in the same period. And so this question says, rubidium has a larger radius than lithium and iodine because. Okay, and again, there are tons of words here. So let's break them down. Let's look for that parallel kind of structure from one answer to the next. And so when I start to look at these, I notice that there's a difference from one to the next in this first part. And so A says rubidium has more energy levels of electrons than lithium, versus C says rubidium has fewer energy levels of electrons than lithium. Okay, so let's think again about where those are on the periodic table. And in this case, again, and let me grab my pointer here, rubidium is down here. It is lower. It is in a lower period on the periodic table, meaning it has more energy levels of electrons. And so if I go back here and think about, okay, rubidium had more energy levels of electrons, so it has to be A. That means it can't be C, but it also can't be D because that says the same thing. So we've just ruled out 2 of our 4 answers. Now we can start to look at what else is different between A and B. And so you'll notice that I've highlighted here, and it says that, so again, reading from the beginning, rubidium has more energy levels of electrons than lithium and fewer protons than iodine, which decreases the force of attraction. Okay, so that fewer protons part is the same for both, but which of those has a greater force of attraction? Well, iodine is the one that's going to have the greater force of attraction. It's further to the right. And so iodine has the greater force of attraction. So, and again, we're thinking for a number of protons here based on its atomic number. So we are seeing that that letter A is correct. So rubidium has more energy levels of electrons than lithium, yes, and fewer protons than iodine. Because it has fewer protons, that decreases the force of attraction between the nucleus and the outer electrons, making rubidium bigger. Okay, so there's our explanation. Let's take a look at our last one. Here we're going to compare these 3 elements. Again, notice that we have calcium and arsenic in the same period, and we have nitrogen and arsenic in the same group. So we're going to rank nitrogen, calcium, and arsenic from smallest to largest, relating to their ability to attract electrons from a different atom. So that ability to attract electrons from a different atom, okay, that's really that force of attraction, but for another atom's electrons. And so that's what we measure with the electronegativity. So remember, that's going to be for atoms that have the greatest force of attraction. And so if we go back here, our greatest force of attraction was going to be in this upper right-hand corner. Okay, fluorine is actually the greediest of our elements. And our least force of attraction is going to be down here by francium. So whichever one is closer to that upper right-hand corner is going to have the greatest electronegativity. So that's going to be nitrogen, and then arsenic, and then calcium. Okay, and so again, we should have, my pointer here, we should have nitrogen, okay, ranked as number 3, that's going to be the largest. Calcium is the furthest away from the upper right, so it'll be a number 1, and arsenic will be a number 2. It'll be right there in the middle. Again, just to say one more time, the thing that we're worried about you knowing the most is about that force of attraction, and the fact that that force of attraction causes all the other, periodic trends that we can observe. It's the why for those periodic trends. Hope that helps a little bit with clarifying our periodic trends. Good luck.